So the second question is to write a small program which shows how dynamic polymorphism work. Dynamic polymorphism in C++ is achieved through the use of virtual functions. There is a term called virtual functions. So it is achieved using the virtual functions. Virtual functions allow derived classes to override methods in a base class, and the decision of which method to call it made at the runtime based on the type of the object. So this is called the dynamic polymorphism. If I explain you using the example, so here I have built a class called animal, publicly virtual function. Virtual void make sound is built. Virtual function is built, which see out animal makes a sound. This is my animal class, which is my base class. Second is the derived class, which derived take the inherit the elements inherit publicly from the animal. So derived class is dog, public void make sound the same function which is in the class animal, but this is the virtual make sound override. So say out dog barks and similarly there is a cat class which publicly inherit animal. In the public void make sound say out cat mews. Derived class cow. Similarly, I make a class which publicly inherit animal, and similar the function makes sound cow moves. Now int main, creating object of different derived classes. I have animal, which is my base class. I've mentioned animal one equals to new dog. Similarly, animal star animal two equals to new cat. Animal star animal three equals to new cow. So here I am creating object of different derived classes. I have different derived classes where cat, dog, cat and cow, and for that derived classes there is a creation of different objects. Now dynamic polymorphism in action where animal 1 makes sound. Animal 1 is the object of my dog class and I'm calling the make sound function. So calls dogs make sound. Okay. Similarly, animal 2 makes sound, so calls cats make sound. Similarly, animal 3 makes sound function, calls cows make sound. So when I click this, when I just write this at the execution, it will call animal 1 that makes sound. This one, dog barks. Secondly, cow mews and then cow moves. This is the cleaner function. So here's a dynamic polymorphism where this is my output. In the first, animal 1 makes sound. My dog barks function, which is the function makes sound in the dog class called, and print dog barks, then cat mews, then cow moves. This is the output. So what is happening? Firstly, the base class animal has a virtual function which is make sound. That is, this is make sound. That is overridden. That can be overridden by the derived classes. So the derived classes is the dog, cat, and cow. Each derived class overrides the make sound function to provide the specific implementation, like dog barks, cat mews, and the cow moves. So what is happening in this case? I have built a virtual function which is a make sound in the animal class, which is the base class. And when I call the function make sound here, of individual classes. So we can say that this function can be overridden by the different derived classes. So each derived class override the make sound function and provide you a specific implementation. Pointer of the type animal star are created at the point to objects of the derived classes. We can say that animal star, animal 1, animal 2, animal 3. So make sound function is called on these pointer. The correct function for the derived class is executed, even though that the type of the pointer is animal. But the derived determine that runtime demonstration, dynamic polymorphism, that when it is running, then it is determining that which functions to be called. So this is the cleanup, and with the help of this example, we can see that the dynamic polymorphism is happening.